and welcome to another episode of Main-iac Science Lab. I'm Mr. Andy, and today we are going to work a little bit with gravity. More specifically, using shapes against gravity. Yes, what we're going to do is use a sheet of paper. This is simple copy paper that I pulled out of my printer that we are going to use to hold a book in the air. It's true. Hopefully several books. What we're going to do is we're going to take these sheets of paper and we're going to fold them into different shapes. And these shapes are going to give structural integrity to these sheets of paper that will help them hold the weight of at least one book, maybe more. So what's going to be happening during this experiment is when you stack the books on the paper, gravity is pulling the books down. The shape of the paper is pushing against that gravitational pull, holding the books up in the air. At some point, gravity will overcome the structural integrity of the paper and crush it or topple it. Gravity will win at that point. The question we have is which shape out of the three we're going to try is going to last the longest and hold up the most weight, thereby defeating gravity longer than the others. So this one's going to be a triangle, this one's going to be a square, and this one's going to be a circle or a cylinder. So let's go ahead and fold our sheets of paper and then we can begin our experiment, okay? So for the triangle, what you want to do is take your sheet of paper and you're going to fold it into thirds because there's three sides to a triangle, right? So if you want to measure out precisely, you can. And as a scientist, I recommend it. But for today's purpose, we're just having a little fun. So I'm going to work with approximations. So we're going to go for about a third to 3/3 of this sheet of paper. So when you stand it up, after attaching the edges, you should have a triangular shaped piece of paper. So I have my handy dandy tape here to close it up to make sure it stays triangular-ish. Which, this is the trickiest part of it all because you want it to be pretty good and have the ends line up nicely. Otherwise, you're already losing integrity with your structure. So be very careful when taping your ends together. Make sure the corners meet very nicely. Also be extra careful not to put any creases in your paper because that can deform your shape and possibly cause some complications in your experiment. So just be extra gentle when working with your sheet of paper. We don't want any extra creases that will cause weaknesses in your structure. Okay, so now I have a triangle. Next is the square. This one's super easy to measure out precisely, or really close to precisely, because all you have to do is fold the sheet of paper in half, line up your corners, fold it in half, open it up, and then fold each side in half again to the center crease. Therefore, dividing your piece of paper into quarters, which will give you 4 sides, which will make a square shape. Now take your time, do a good job. Measure 3 times before you make your crease. All right, now you want to fold it. Open it up a little bit, fold it straight up, and then add your tape for support. One at the top, line up our corners. One at the bottom, line up the quarters again. You can't assume they're going to line up just because the top is taped up well, because paper is very flexible and will bend and might not necessarily line up without extra care being taken. Okay, so I got my corners perfect. There we go. I'm going to put one more piece in the middle because it already looks like it wants to kind of bow out in the middle there. Go. And now I have my square. And then the last one, the cylinder. Also very easy because all you do is just kind of curve the paper. Might be easier to go ahead and put the tape on first. Make sure you put it on the outside. 3 little pieces, 1 at each end and 1 in the middle. And then when you roll your paper to the edge, make sure it's lined up right before you seal it. Oh, it gets a little tricky. Oh no, I've already sealed it and it wasn't even lined up right. Hopefully this doesn't affect the integrity of my paper too badly. Sticky stuff, it's challenging. Even Mr. Andy has a hard time with it sometimes. Okay. So now we have our cylinder. So triangle, square, circle. Which one do you think is the strongest? Which one do you think is going to fight off the gravitational pull the longest? Well, this should be fun. So are we ready to put some books on and see? Have you made your guess? Have you decided which one it's going to be? Okay, let's begin. I have a couple stacks of books approximately equal in weight, and we're going to add them one at a time to each structure and see what happens. So, now you want to make sure you set your books down very gently, very carefully, and very evenly, because you don't want too much weight on one side. Oh, I think I went with too heavy a book to begin with. Let's try a lighter book. Triangle's not looking so good. I hope you didn't pick triangle. Oh, wow. Triangle's not looking good at all. Let's go with the lighter book. The lightest book I have. Oh, triangle. I'm not too confident in the triangle. Let's try the square. Let's get a book on there. I guess we're going with the lightest book possible. So this is my lightest book for my square. Set it down gently and evenly. Not too bad. It held pretty well. Guess I should put my books where I can reach them easier. Let's put them down on the ground. Da, 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 da. So triangle is already looking pretty lousy. I really hope you didn't guess. You can see the edge here is like warped. It is already starting to fall down, and it only has one book on it. Square is looking pretty good, though. I'm feeling good about square. How about circle? How's he gonna do? Let's find out. Copy the BFG. All right. So far, one book each. Doing pretty good. Triangle's not looking so good, though. I guess we should try another book. I got a feeling this one's going down. Let's see. Triangle, not so good. Held up one book, could not handle two. Let's see if square can handle two books. Hey, not bad. I'm seeing a little warping on the edges. All right, circle, you're up next. All right, so we got two books on each one. Let's try for three. Third book on square. Ooh, it's doing okay. I think I'm I'm afraid to adjust. I was a little off in my placement. Let's go for a third one on cylinder. Not bad. Okay, book 4. Here we go. I'll put one over this way because I think we're getting a little heavy on one side. square collapsed. Now, can cylinder take a fourth book? Triangle did 1. Square made it to 3 before it crushed. How far can we go with cylinder? Book 4. Whoa. Did you choose the cylinder? Did you pick that one? If you did, well, already you're right. Now the question is, how much farther can we go? Let's add another book. Do you think it can take a 5th one? Let's find out. 5 books. Triangle only took 1. Square took 3. Cylinder's at 5. Oh, goodness, that's a heavy one. I'm afraid to do that one. Let's do a not so heavy one. Here we go. 6 books. 6! Oh, boy. They're so heavy, the books themselves are folding over. How crazy is that? But it's still holding. Okay, book 7. Is 7 the lucky number? Let's find out. It's holding 7 books. I'm so nervous now. I have a feeling it's going to collapse at some point. So what's happening is the weight of the books is being pulled down by gravity, but the structure of the paper cylinder we created is pushing up against that force and is winning at this point. And the reason the cylinder did so much better than the triangle and the square is because the force of the structure, the push of the structure, whatever you want to call it, the force of gravity of the supported books is evenly distributed throughout the cylinder, where with the triangle and the rectangle, each crease in the paper breaks up the structural integrity. So you have 3 sides of structural integrity and 4 sides of structural integrity, but the 4 sides are smaller, but they did better. This is like one solid piece going up and down, and it's currently holding 7 books. Let's see if we can go to 8. Oh. All right, here we go. Book number 8. Oh, we pushed our luck. But the cylinder, it finally crushed under the weight, but it took 8 books to crush it. So, in summary, the triangular shape of paper was only strong enough for 1 book. The square shape of paper was only strong enough for 3 books. The circle was able to hold 7 books without any problem. It was the 8th book that finally helped gravity win the battle. So now you know, when creating structures and structural supports, cylindrical or round structural supports are the strongest and the less prone to weakness. So when you look at a lot of ancient sculptures, ancient architecture, or bridges, buildings, that kind of thing, a lot of cylindrical supports, very, very strong. And they hold a lot of weight, much more so than a triangular support would or a square one would. So now you know. Next time you design that fancy building or that fancy structure or that bridge, think cylinders, because that seems to be what works the best. At least in this very not terribly scientific experiment that we tried, but it does illustrate a very good scientific point. So, for Main-iac Science Labs, I'm Mr. Andy. I hope you had some fun. I hope you learned something. I hope you didn't drop books all over the place or knock anything over accidentally. But I hope you enjoyed it, and I hope you continue learning and experimenting and exploring and trying new things. For Main-iac Science Lab, on behalf of the St. Johns County Public Library System, I am Mr. Andy from Main Library, saying goodbye until next time.